Hello and welcome to our review of trigonometry from first semester pre-calc. What you see is the unit circle with all of the special triangle or special angles identified in radians and in degrees with the trig ratios out there at the points. The regions, we would say that all scholars take calculus, meaning that all trig functions are positive. In the first quadrant, just sine. In the second, just tangent. In the third, and just cosine in the fourth. That's a nice way to make sure that your answer is correct to the in the sign anyway, S-I-G-N. And let's do some of these problems. That for point A, the angle in degrees, 30. For B, it's 45. And for C, it's 60. D is all the way around to 90. In radians, we call that pi over 6, pi over 4, pi over 3. And one of the ways to think about that is the 45 has a 4 in the bottom, and then the 30 has a 6, and the 60 has a 3. It's kind of flipped as far as the number you might see on the bottom. And then 90 is a pi over 2. It's halfway around to 180. Our coordinates are, and in this quadrant, they're all positive. The point A would be root 3 over 2 comma 1/2 on the unit circle. Again, that makes the hypotenuse 1. Root 2 over 2, root 2 over 2. And now it flips. The cosine is 1/2, and the sine is root 3 over 2, the longer side. And at 90, we have 0, 1. And you might want to throw in a 0-degree angle, which is still 0 radians, and its coordinates are 1, 0. Okay, try these. You might want to draw a unit circle and put a triangle there. Cosine of pi over 2 is going to be a 90-degree angle. And we think of cosine as our x, sine as our y. In this case, the point up on top is 0, 1. So we would say that cosine equals 0. Sine of pi over 6, that's going to be our smaller angle here. The opposite side is 1/2 for a unit circle. And then tangent pi over 4. That's like our 45. What we know there is that the opposite and the adjacent have the same length. Tangent's positive in the first quadrant, so that's a positive 1. Now let's extend this around the unit circle and get our reference angle. I tend to think of the far left, the 180, is pi or 3 pi over 3 or 6 pi over 6. And then of course all the way around, that would be 2 pi or 6 pi over 3 or 12 pi or 6 pi over 3 or 12 pi over 6 if I'm talking about thirds or sixths. All right, sine is 7 pi over 6. Well, over far left at pi is 6 pi over 6. We go one more. All but tangent are negative down here, so the sign being the opposite, negative 1/2. Negative pi over 4, now instead of rotating around counterclockwise, we will be rotating around counterclockwise. That puts us down in quadrant 4. Only cosine is positive there, and so our cosine will be root 2 over 2. And then tangent of pi. Pi is over on the far left. We could think of those coordinates as negative 1, 0. Tangent is the same as sine over cosine over y over x. So if we know that sine is the y, in this case 0, and cosine is the x, -1, we would see that tangent of pi is 0. One-third, two-thirds, whoops. Continuing on, we know 1/3, 2/3, and then this of course is 3/3 pi. So 4/3 is going to be down here. The reference angle would be like a 60 or a pi over 3. And down here tangent's negative, positive. And we would get, this is the short side, -1/2, -3 over 2. So we would get opposite over adjacent. Negative over negative is positive. Rather than dividing by a fraction, we can multiply by the reciprocal, -3 over 2 times -2 over 1. The negatives cancel and the 2's cancel. We get positive root 3. Sine of -2 pi over 3. Again, 1, 2, and then this would be -3 pi over 3. So down here, our reference angle, remember you always draw your perpendicular to the x-axis, never to the y. And 2 pi over 3, that'll be the shorter side on the x-axis, so a -3 over 2. A lot of times kids get a little confused on the angles and radians and the radical. So if they see a pi and they see a radical, they sometimes get confused on what is a ratio and what is an angle. Remember, when you take the sine of an angle, and radians are in pi units, your answer will be a ratio. If we likewise took the inverse sine or inverse cosine or inverse tan of a ratio, we would get out an angle. Last here, 11 pi over 6. Go with blue. I know that all the way around is 12 over 6 pi. So 1 short will give us our 30-degree reference angle, or pi over 6. Cosine is positive here. The longer side is on the adjacent. So positive root 3 over 2. And now to graph, just in general, I'll go through this fairly quickly. If we were ever going to graph, and let's say k was some positive value, we draw a dashed line through the middle. And then A is the amplitude above and below, how far above and below that our stretch is. And then our B is the thing that stretches it horizontally or vertically, and that to find the period, we would just do 2p over b. So whatever our period might be, we would have our graph start. In this case, a sine starts in the middle. And whatever our period would be is where it ends. So if in this case I put a h of 0, the sine hits its middle again halfway through the curve. It goes to its max for the first fourth, and to the bottom its minimum for the third fourth of its life cycle. And we get something like this. In this case, we'll label all of our values and then go ahead and sketch the graph. So we have k is 5, a is how far above and below is 4. It's always a positive value. The b is pi over 7. So our period, 2 pi over pi over 7, becomes, the pi's cancel, becomes 14, and then h is a 3. And notice when we have a b that has a pi in it, our h will not. And because the pi's cancel out when we do our period. So in this case, we'll label things and get this thing graphed out. The k is at 5. And then if I go up 4 and down 4 from there, still stay at the positive. So I graph k, then I graph a. Then I'll jump down to the h and just label it 3. This is a sine curve, again starting in the middle. With the black, I guess. And then the period being 14, I just add 14 to 3, puts me at 17. Again, sine curve starts and ends in the middle. Halfway through is in the middle, goes up to its max, down to its min. So something like this. Right. Go ahead and try this one. See how it goes, and then I'll sketch the graph. All right. K is 1, A is 3, the B is pi over 4, meaning period is 2 pi over pi over 4, or 8, and the H is 2. So I start up at 1, I go up 3, and down 3, putting me down here at negative 2. Starting at 2, again a sine curve, need to get a cosine in there, and the period is 8, so I add 8 to 2, I'm out here at 10. Halfway through in the middle, above and below. Oh, that's not going to look pretty. So let's cut this guy out a bit more in the middle. Something like this. It's not an art class. You should be somewhat dimensionally correct, but okay, we've got a similar graph here, a cosine. However, our B and our H are a little different here. Let's see how that affects our graph. Our K is negative 2, our A is 5, B is 1/2, meaning 2 pi over a half, or 4 pi is our period, and we start pi units. It's a good thing when our H, our horizontal translation, and our period are in the same units, in this case units of pi. And since this thing starts on at negative 2, I'm going to move my axis a little bit here. We're down at negative 2, going up 5 and down 5. And starting at pi and ending 4 pi later, that's out here at 5 pi. This is a cosine curve which starts at its max, ends at its max, halfway in between would be here. So 2, 3, 4, somewhere in here. Oops. And then it's tempting to put a dot on the x-axis. You want to put it on the sinusoidal axis for the symmetry you need. And there you go. There's the sketch of this graph. Here is an equation that we want to find from a graph. So we're going to find our k first. Our k will be halfway between, which means 9 plus negative 1 over 2, which is 8 over 2, which is 4. So we look at this and say at 4, and then it goes up 1, 2, 3, 4. Up and down 5, that's our amplitude of 5. Our b we don't know, but we can find our period. It looks like a period goes from pi to 2 pi, so a period of pi means b is 2 pi over pi, or 2. And then we're going to use a cosine curve that thankfully starts at 0, or you could say it starts at pi or 2 pi, but we're going to just say 0. And using cosine, we would get y equals the k, 4 plus 5, cosine of our b being 2, x minus 0, or any other. We just put x there. And that is our equation. And one of the ways to do the k, it's basically the average. So if we took the max plus the min and divided by 2, in this case, this is 9, and it goes down to negative 1. So 9 plus negative 1 is 8 over 2. My k is 4. The a is how far above and below. And we could count 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. The other way to do it is the max minus the min over 2, which again would be 9 plus 1 over 2, or 5. The b we get from the period, so if we find our period to be 2 to 12, that total distance is 10. So our period being 10, b is 2 pi over 10 or pi over 5. And then h, where it starts, if we start with a cosine curve, it started at 2. So our equation would look like 4 plus 5. We're using a cosine curve. It's usually easiest to use a cosine because its max is easier to find than some middle point of a sine. b is pi over 5, and then x minus 2. And again,